It's Ms. Vernon, and today I'm here to teach on lesson 5.6a, which is graphing inequalities with two variables. So if you remember, we learned how to graph inequalities on a number line with just one variable, and that was just on a number line. We drew an arrow and we used open or closed circles to represent them. Today, we're going to talk about how to solve two variable inequalities for y, and then graphing those on a number or on an xy coordinate plane. So when we are graphing inequalities that have two variables, we have a few steps that we are going to follow through. Now, if you have a highlighter or have a pencil that you can make notes around this, it's going to be very helpful for you to remember these three steps. So step one of the process says we want to solve the inequality for y. Now, with an inequality, instead of the equal sign, we're going to have the inequality, but basically it's solving so that it's in the form that allows us to graph. Okay. Step two of the process says that we are going to graph it. Now, we are going to, depending on the inequality that we're given, either use a solid line or a dotted line. If it's or equal to, we're going to use a solid line. And if it's just less than or greater than, we're going to use a dotted line. The third and final step of the process is to plug in a point. I like to plug in the point 0, 0, unless that point is on one of your lines, because it's an easy point to calculate and it just works really well. So let's go ahead and go through an example together. I'm just going to go ahead and have us focus on example A right now. And so in example A, we are graphing the line y is less than 2x plus 3. So notice that y is already by itself. So with this problem, I'm ready to state the b value, which is 3, and the m value, which is 2 over 1. Notice the m value is attached to the x, and the b value is 3. It's the number by itself. So on my graph, I'm going to put a dot at 3, and then I'm going to go up 2 over 1, up 2 over 1. And that's applying the slope. Slope is rise, rise up 2, go over 1. Now I'm going to choose to use a dotted line. The reason I'm using a dotted line is because the inequality is just less than. It is not or equal to. And so we are going to use a dotted line to graph this. Now I'm going to use my line tool here just to make it a little more precise. It's a little hard to graph dotted lines sometimes on here. So there we have our line. Now, technically, the next step of the process that was described above was to test a point to see if the points were true or false. And what that means, and we have a couple points for us to test here just to show you how that works, is you're going to plug in x and y to your inequality, and you're going to determine if it's a true or false statement. So I'm going to go ahead and do this first one just off to the side over here so I have a little more space. But y, so 2, is less than 2x, so 2 times negative 3 plus 3. All right, so we have is 2 less than negative 6 plus 3 or negative 3? Is 2 less than negative 3? And in this case, I would say, nope, that one is not a true point. So if I plotted that point over here, I would be 1, 2, 3, and up 2. So that means I don't want to shade there because that was not a true point. I can keep plugging in values, but if that turned out to not be true, that means any point that fell on that side of the line is not going to be true. Let's go ahead and test another one. This one is negative 3, negative 3. Now that falls on the dotted line. Do you have a prediction of whether or not that would be true? Why don't you enter that there and just kind of think about it. We're going to plug in these numbers and check it out though. So we would have -3 less than 2 times -3 plus 3. So 2 times -3 is -6, and -6 plus 3 is 3. Is -3. So is -3 less than -3? And hopefully you said, no, they're the same. So again, that point is not true, and dotted lines are not going to be included, which is why you would say, yeah, that shouldn't have made much sense. Let's go ahead and test the last point, which is 2, -1. Notice this point is falling on the other side of the line. But let's plug in our numbers and check them. So we have -1 less than 2 times 2 plus 3. Well, 2 times 2 is 4, and 4 plus 3 is 7. Is 7 the better deal here? And hopefully you said yes. This is a true statement. And what that means is on our graph, it means any number that falls over on this side of that line is going to be a true number. And so those are the ones we're going to keep as our final answers. All right, let's give another one a try. Normally, we won't test that many points. We just tested that many points to show you the process. All right, let's take a look at example B. In example B, the first thing we check is it solved for y? And in this case, it is. So we're ready to identify the b and the m. The b value or y-intercept is 2. It's the number by itself. And in this case, there's an invisible 1 in front of the x. So our slope is -1 over 1. If we're plotting this, it means we go down 1 and then to the right 1. So we're going to start at 2, and we're going to go down 1 over 1, down 1 over 1. Now, the next thing I need to do is I need to consider my inequality. In this case, my inequality is greater than or equal to, which means I need to use a solid line. I use a solid line here. Sorry, my spelling was a little off, so I'm going to fix that up for us. We use a solid line here because it is or equal to. So I'm going to grab my line tool here. Again, I like to make sure that I have it the same color that I've plotted my points just to make it easier on us. And I'm going to graph a solid line. Now make sure your graph of your line goes all the way. If you need to plot more points to help make it more accurate, you can definitely do that. So we have found our solve for y, found our slope and y-intercept. We've graphed the line and used a solid line because it was or equal to. The next step of the process is to test a point. Again, my favorite point to test whenever possible is the point 0, 0. It's a quick, easy calculation because anything times 0 is 0. So when I plug that in, I'm going to have is 0 greater than or equal to -0 plus 2. So is 0 greater than or equal to 2? And hopefully you're able to say, no way, that is not true. Therefore, this side or below the line is not a true statement, which means we need to shade on the top of the line or above it. All right, let's move on to the next problem. In the next example, I encourage you to pause and sketch the graph. Also, make a note. Are we going to use a solid or a dotted line? All right, I'm back. Let's start by identifying is y by itself? Check. Next, the b value is 4 and the slope is 2/5. So I'm going to start at 4, 1, 2, 3, 4, and then I'm going to go up to over 5. So I'm just going to double check my counting. The worst thing that happens is when we make a mistake when counting. Next, we need to determine, is it solid or dotted? Because it is or equal to, you should be saying, this is a solid line, Miss Vernon. And you're right, it is. So I'm going to grab my line tool and I'm going to connect the dots, creating a solid line. Next, the third and final step of the process is to test a point. All right, which point is my favorite point to test? Yep, that's right, 0, 0. So if I plug in 0 for the y and for the x, I end up getting, is 0 less than or equal to positive 4? All right, well, is that a true statement? Yes, it is. 0 is less than or equal to 4, which means I'm going to shade on the side of the line that has 0, 0. Or in this case, I'm going to shade below the line. Great job. We've got 2 more examples for us to try today. Go ahead and pause the video. I want you to complete this entire problem. I want to see if you can do it on your own without my help. All right, let's take a look. Step 1, y is by itself. Identify the y-intercept and the slope. The slope in this case is negative 4 over 3, which means I'm going to go down 4 and to the right 3. The y-intercept was negative 5. All right, plotting my points. Now notice when I try to graph this and go down 4, I end up way off the graph. I can still plot the point, but it's not going to be as accurate. So I'm going to make sure that I reverse the direction. So I'm going to go 1, 2, 3, 4, 1, 2, 3, and shift over 3. Now, notice that my slope is still negative, so I am still maintaining that negative slope. Next, we're going to look at our inequality, and I see that it is not or equal to, so that tells me I need to use a dotted line. I'm going to go ahead to my line tool, and I'm going to connect those dots that I've created so that we can now have our graph of our line. All right, we're ready for the final step of the process, which is testing a point. And again, I like testing that point 0, 0 whenever possible. It's just a nice point to find, and it's super easy to work with in your equation. So if I plug in 0 for my y and for my x, I end up with, is 0 greater than negative 5? And hopefully you say, yes, it is. And because of that, this is a true statement. It created a true inequality. So we're going to shade on the side of the graphed line that had the point that was true. You guys are doing just a great job with this today. All right, last problem for today. This one's a little bit more involved. We got to do that first step that we haven't had to do so far in the process. This problem, y has not been solved for. So we're going to begin by getting y by itself. To do this, we're going to subtract 2x from both sides. This gives us negative 3y is less than or equal to 6 minus 2x. Next, we're going to divide all the different terms in the problem by negative 3. Now remember, if we divide by a negative number, that inequality needs to switch directions. And that, when I go back and do my division, I get negative 2 plus Two negatives divide to be a positive 2/3 x. Now that y is by itself, we can go ahead and graph this problem. When we go to graph, we will acknowledge that the b value or y-intercept is -2 and the slope is 2/3. Plotting the information I have, starting at -2, going up to over 3. Again, I can plot as many points as I need to if it makes it easier for me to graph it. Next, I need to connect those dots. When I go to connect the dots, I'm going to use a solid line. Who remembers why we're using a solid line? That's right, we're using a solid line because the inequality in the problem was or equal to. Remember, this is or equal to. Next, we're going to go ahead and test our point. Now, I have a whole list of points down here, but we're going to go ahead and test our comfort point 0, 0. So we're going to test the point 0, 0, and then I'll show you how we can determine if these are going to be solutions without actually plugging them all in. So when I plug in 0 for x and y, I'm going to get 2 times 0 minus 3 times 0 is less than or equal to 6. Well, 0 minus 0 is 0. So is 0 less than or equal to 6? And you should tell me, yes, it is. So this is true, which means we're going to shade above this line. Now, I don't want to have to plug in all those different points. So instead of having to plug in all those different points, we're just going to plot them. If they fall on the side of the line that's shaded, I know that that point is in the shaded region. If it falls on the side that is not shaded, it's going to produce a false answer or a false inequality. So let's plot the points. 3, 0. 1, 2, 3, 0 up. It falls on the line, but this line is solid, so it is okay. So is this a solution? I would say yes. Next one, -3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Yep, that's definitely in the shaded region. I would say that's a solution. And last but not least, 5, -2. That is not in the solution region. So I'm going to say, nope, that is not going to be a solution that will produce a true inequality. I hope today's lesson on graphing inequalities with two variables made sense, and I look forward to seeing you in class. Bye.